Section 4.3. This section, we are going to look at the vertical translation and the phase shift of the sine and cosine graphs. Recall the relationship between the graphs of y equals f of x and its translation. For the general function, this case on the diagram, you see y equals square root of x. When you multiply the square root x by 3, the graph is stretched vertically. When you multiply by 1/3, the graph is compressed vertically by the factor 1/3. Refer to the last section or the previous section. We consider what happened to the graph when we allow for a coefficient or a multiplier with a sine and cosine function. As you see y equals cosine x, this one the amplitude, which is the a value of this pattern, the amplitude is 1, or the absolute value of the a equals 1. But if you multiply the cosine function by 2, the a value equals 2. So the amplitude, which is the absolute value of the a, equals 2. For the case that you have the coefficient as negative sign, like y equals negative 2, multiplied by cosine x, this case, the a is negative 2. The amplitude equals the absolute value of negative 2 equals 2. But since a is negative, so the graph has reflection about the x-axis. Similar to the case of y equals square root x and y equals negative square root x. The other translations, this time, if you add or subtract the numbers or insert a term in the equation of the function, so this will cause the translation in the position, not the shape. So the graph remains the same shape. For example, y equals x squared. When you add 3 to the x before you squared, the graph moves to the left 3 units, the same shape. If you subtract by 2 before you square, the graph moves to the right 2 units. And the other case, when you add 1 to the function, the graph goes up by 1 unit. When you subtract 2, the graph goes down by 2 units. These situations, the shape remains the same, just the position of the graph changes from one to the next location. In general, the graph of y equals f of x plus k is the graph of y equals f of x that translated k unit vertically. I should put the absolute value of the k. So in the case that k is positive, the graph translated upwards. For the k less than 0, the graph translated down k units. In summary, for the graph of sine and cosine, that's added by the term k, so these two graphs will be translated vertically, k unit upwards if k greater than 0, and k units downward if k is less than 0. I will put absolute value here because we look at the quantity. So the graph goes up or goes down by the quantity k, not the sign. The sign will tell you up for the positive side and down for the negative side. The phase shift. This case, we add a term to the argument of the function. The graph will be translated in a horizontal direction instead of the vertical direction, like the graph of y equals the quantity x plus 3 to the second, which gives the translation to the left 3 units. For the graph of sine and cosine, we have the pattern as y equals sine of the quantity bx plus c, or y equals cosine of bx plus c. So with this pattern, we're gonna identify what are your b value and c value. The negative c over b units will tell you the new position of the graph or the beginning of the graph, which is called the horizontal translation. So the value negative c over b is called the phase shift, which is the beginning of the graph of the original or the basic cycle, or the graph begins the cycle at the phase shift point. For the note here, y equals cosine of bx plus c. If you factor the b out, that means we have another term in the form of cosine times b multiplied by x plus c over b. In this case, you can see the value negative c over b comes out from the factor form of this pattern. In summary, graphing the sine and cosine functions, if c is any real number and b is greater than 0, then the graph of y equals k plus a times sine of bx plus c and the graph of y equals k plus a times cosine of the bx plus c will have these properties. The amplitude is absolute value of the a, the period is 2 pi over b, b is the coefficient of the x in the parentheses, the vertical translation is k. The reflect about the x-axis happens if the a is less than 0. The phase shift is the position negative c over b. Recall, if you factor this, it's going to be b out and then x plus c over b. So then negative c over b will be the phase shift of the graph. The range is from the basic graph, which is from negative a to positive a, but it has a translation with the k units in the vertical way. So you're gonna add k to both max and min, or the basic range of the graph. That's why it becomes the range as the left end is k minus quantity of the a and k plus the quantity of the a, or the absolute value of the a. Let's see the first example. We're gonna suggest the graph, like one complete cycle of the graph of y equals 1 plus cosine x. We rewrite it in a pattern of y equals k plus a times cosine of bx plus c. With this way, we identify the k equals 1, the a equals 1, the b equals 1, but c is 0, because if you rewrite this as 1 plus 1 times cosine of 1x plus 0. From these four numbers, a, b, c, and k, we can summarize the property of the graph as, for the value of the a equals 1, tells you that the amplitude, which is the absolute value of the a, equals 1, and also the a is greater than 1, so then no reflection about the x-axis. The value b, which is 1, will tell you about the period. To compute the period, the formula is 2 pi divided by b. So the period is 2 pi divided by 1, or just 2 pi. When you suggest one complete cycle, we're going to break it up into 4 equal subintervals. And 4 equal subinterval width is from the period divided by 4, which is 2 pi divided by 4, or pi over 2. That means we can create 5 key points with the increment pi over 2. The phase shift that we're going to use the b and c value, which is negative c over b. The c is 0, the b is 1, so the phase shift is 0. Therefore, the beginning point of the 5 key points start at 0. And then use the increment pi over 2. So the next one is pi over 2. The next one will be pi. and then 3 pi over 2. And the last of the 5 key points is going to be 2 pi. The phase shift is the beginning point of the cycle. And another number, the k value, the k equals 1. The k tells you about the horizon, the vertical shift. Equals k, which is 1. So that means the graph will go up 1 unit. And this number gonna tell you that the range of the graph will be the interval of the k minus the absolute value of the a, k plus the absolute value of the a, which means you have from the a, from negative a to positive a, gonna be negative 1 to positive 1. For this case, gonna be 1 minus 1, comma 1 plus 1, or the interval 0 to, as we can find out from the table as well. So the table is completed. I'll show you real quick how to work on it. Recall the 5 key points of the cosine function. From the unit circle, the cosine is the x coordinate value. So starting from 1 here, and then 0, and then negative 1, 0, and back to 1. The graph will be from the maximum 1 down to the minimum and up to positive 1 again. That's why when you complete the table, the quick way to complete it, after you identify the 5 key positions here, x0, x pi over 2, x pi, x 3 pi over 2, and 2 pi. So rewrite the function as 1 plus cosine at 0, 1 plus cosine at pi over 2, and so forth. And then at the position, at the value of the cosine 0, the value is 1. Cosine at pi over 2, the value is 0. Cosine at pi, the value is negative 1. Cosine at 3 pi over 2, the value is 0. Cosine at 2 pi, the value is 1. And you see the list of the numbers for the 5 key values, 1, 0, negative 1, 0, and 1. That's what you fill in the box right there. And after that, you put them together in the order pair form, x0, y2, x pi over 2, y1, and so forth. And then we're going to suggest the graph by plotting the order pairs on the xy plane. Starting from the first shift, which is the point x equals 0, but the function value is 2 at pi over 2. So I'm going to make the increment 1, 2, 3, 4. So let's go with one mark here for pi over 2. This is pi, and this is 3 pi over 2, and then 2 pi. At pi over 2, the function value is 1. At pi, the function value is 0. At 3 pi over 2, the function value back to positive 1. This is 1, this is 2. And at 2 pi, the function value is 2. So after that, we're going to connect all the points with a smooth curve. It is the graph of the cosine. The shape is the same, but the graph is shifted upward or shifted vertically with the value k or by the value k or 1 unit. So if I suggest the original graph would be the graph in the dark curve here. So I'm gonna write in the dashes form. And make it as a solid curve here. The pink curve here is the curve of y equals 1 plus cosine x, where the dashes curve here is the graph of the basic graph y equals cosine x. So the change is just the graph is shifted upward by 1 unit.